Hello, seventh graders. This is going to be lesson 7.2, writing inequalities from word problems. So we will be working on pages 211 through 216. If you need to pause the video, I will begin in a moment. Please get your math book. Okay, so our standard today is going to be standard EE4. I can use variables and inequalities to represent word problems. So that's what we're going to be working on. My first problem I want to do is on page 212, number 4, and I've gone ahead and typed it out here. So we have 212, number 4, if you want to turn to that. Just leave a little bit of space here. So we have Ella has $40 to spend. I'm going to underline the problem, the words as I go and the numbers as I go. Ella has $40 to spend at the state fair. Admission is $6 and each ride costs $3. Write an inequality to find the greatest number of rides she can go on. So we have some numbers in our problem. So the $40 is the total amount she has to spend. So she cannot spend over $40. And she has to pay a one-time admission fee of $6 to get in the fair. And then she pays $3 for every ride that she rides. So the first thing we want to do when we're writing an inequality is figure out what our variable is going to represent. So in our case, we're going to let R equal the number of rides that she can ride, right? So I always pick a variable that represents the thing that I'm looking for. So I picked R because it represents rides. Now we know that she cannot spend more than $40, but she could spend up to 40, so it should be really less than or equal to. So I should have a little line under that. So let's put a little line under there. I don't know how to make a greater than or equals to sign onward. So I put the little line afterwards. In fact, it should be up a little bit higher. Let's kind of move it up a little bit there. No, it disappeared on me. Oh, there it is. Okay, let R equal the number of rides. And now we have to figure out what goes on the other side. And we'll even this all back out in a minute. So we have $6 admission. So plus $6 is the admission fee. That's a one-time fee. That's a fixed rate, one time. And then we have this $3 per ride. So that's $3 every time she rides a ride. So let me ask you, if she was to ride 2 rides, how much would she pay for that? Yes, she would pay 3 plus 3 or $6. How much would she pay if she rode 3 rides? 3 plus 3 plus 3 or $9, or you could say 3 times 3, right? So it's really the number 3 times the number of rides. And I'd like to make this a little bit closer. There. So we made our equation. 3R plus 6 is less than or equal to 40. Now in the next video, we will talk about how to solve that. It's basically the same way that we have used to solve the expressions when we had the equals to sign instead of the greater than or less than sign. However, we will wait till the next video to go ahead and solve that and figure out how many rides she could actually ride. So the next one I want to do, clear my board here. The next one I want to do is number 5. So let's insert a page break so it stays on the same page. Page number 5 on page 213. So this time they want you to write a word problem from the given information. So they give us this information here, and they want us to write a word problem. So I'm going to use Michael for this. Hope you don't mind, Michael. So we're going to say that Michael owes Victor, oops, use Victor too. Michael owes Victor $30. Now I'm going to have to add a little line under this because the situation I'm using is going to include or equals to. So Michael owes Victor $30. He, or Michael, decides to get a job to pay Victor back. So Michael's idea is to hold a basketball clinic for the second graders. Granted, the coronavirus has disappeared. It's no longer something where you have to be quarantined. So we're assuming that the positive on that. So his idea is to hold a basketball clinic for the second graders. Michael will charge $3 per student. Now, I'm going to have to figure out my variables. So I'm going to let S, what do you think it's going to equal or represent? The number of students in Michael's clinics, right? Okay. So Michael will charge $3 per student. And we have this $10 here, right? So we have to figure out what that's going to represent. Well, I thought we could say that Michael's grandparents give him $10 to get his business started. Now we know all together that Michael needs to make at least $30 or more. If he makes more than $30, he gets to keep the extra, but he's got to pay Victor back $30. He's already got $10. So now we have to figure out, what could we have to figure out here to make this word problem work? Great. We have to figure out, so we'll ask it in a question. How many students does Michael need to make at least $30 at the basketball clinic? See if that makes sense. So go back up here and look at it. This expression here needs to be greater than or equal to 30. He charges $3 per student. X is our students. In fact, we're going to change that from an X to an S. I always think to use the variable that represents what we're talking about. And the $10 is how much his grandparents gave him to just get his business going. So now we could solve that for S, and we'll do that in the next video, but we had to just write the equation in this case, and that is our equation. So now if you need to pause the video, go ahead. We are going to be on page 214, the guided practice page. Okay, we're ready to begin. This is page 214. I'm going to start by saying you do not need to do numbers 1 or number 2. We're not using algebra tiles, so completely just skip those 2 problems. So we're going to go on to number 3. So let's take a look at what it's asking. Let's read our word problem. The Booster Club needs to raise at least $7,000. When I see the word at least, then I know we're going to deal with an inequality. $7,000 for new football uniforms. So far, they have raised $1,250. Write an inequality to find the average amount each of the 92 members can raise to meet the club's objective. So they're saying let A represent the amount each member must raise. So A equals amount. I'm going to put that in here right here, just nice and big. Let A equal amount. So we know that that's standing for the amount that each person has to raise. Let's put it right over here. And the amount to be raised is how much? Back at the problem. Yeah, $7,000. Let's put that in there. $7,000 needs to be raised. And how much has already been raised? Back to the problem. Exactly, $1,250 has already been raised. And how many members are there? Easy peasy, right? 92. right in the problem. Okay. All right, use clues to the problem to write an equation. So this box is the amount already raised. Start my text box again. Amount already raised. I don't know if that's going to fit in our box, but we're going to try to get it there. Amount already raised plus, what goes in the other box? The number of members. Number of members. And times, number of members times the amount each member raises. I don't know what that little blue square is. The amount each member raises is going to be A. So we're going to stick that in there. Right here. And we might as well go ahead and put the number in the other box. The number of members, we already know that to be 92, so we can stick that in the box. So 92 members times the amount each member must raise plus the amount that they have already made, which is right there. They made $1,250 plus 92 members times the amount that they each are going to raise. And this greater than or equals to is the amount each member raises right here. And this box here is greater than or equal to. That's what that's saying. Is greater than or equal to. Put that in there like that. And what number do we put in this box? Yeah, 7,000. So 7,000 in this box. They have to raise at least $7,000. So $7,000 or more is another way of saying it. So our left side has to be greater than our right side. The inequality, and let's move myself up here for now. The inequality that represents the situation is, how would we write our formula for this, or our expression, our equation? 1,000, it's already there for us, 250 plus 92A is greater than or equal to 7,000. Should be greater than or equals to, I got to put that little line there again. Here we go. Okay, makes sense? Great. I'm going to clear it. If you need to pause the video, go ahead, get that written down in your book. And when you're ready, come on back. I'm going to clear it. 3, 2, 1, voila. Okay, we're going to move up a little bit if we can. Doesn't look like we're able to move up at all. So, number 4, grab my spotlight here. Analyze what each part of 7x minus 18 less than or equal to 32 means mathematically. So x is the solution, which we'll be figuring out how to get in our next lesson. X is the solution. 7x is, remember, any number of coefficient times a variable is a rate of some sort, right? It's the solution multiplied by 7. So solution or variable multiplied, we'll just say times 7. Shorten it up a little bit. Solution times 7. Negative 18 means that, what do you think? It means that 18 is subtracted from 7x. And then less than or equal to 32 means that the result must not be larger than 32. Let's try to stretch that out so it fits a little bit better. And then number 5 says to write a real world problem for number 4. So what did I pick for this? All right, I hope Destiny doesn't mind. I'm going to use her in this. So Destiny, I hope you don't mind. Destiny likes, oops, not Destiny, Destiny. And we'll put an underline there and get rid of that. Destiny likes to buy a vanilla latte for $7 each. She has a gift card that originally had a balance of $32 on it, right? She has, what do you think I'm going to say? She has already spent, what do you think? Exactly, $18 from the gift card. And I want to say that, I'm going to just put this up at the top. We're going to let X equal the number of vanilla lattes Destiny can still buy. So Destiny buys a vanilla latte for $7 each. She has a gift card that originally has a balance of $32. She's already spent $18. We know that they cost $7 each. So the question is, how many vanilla lattes can Destiny buy using her gift card? You just kind of have to look at the numbers in the problem and come up with a situation. So you have to figure out what your variable is going to represent. And that's kind of what number 6 is asking. You can't see it on the screen there, but it says, describe the steps you would follow to write a 2-step inequality you can use to solve a real world problem. So basically, you're just going to figure out what your variable is going to represent. You're going to have a rate, and you're going to have a constant. I always find that money works really well, and coming up with situations using money seems to be easier for students than trying to come up with something else that's a little bit more obscure. All right, next we are going to talk about the homework. So I'm going to go over here. So the homework is to go back through the guided practice, page 214, the problems we've just done. And then we are going to, I'm just going to clear out this other stuff. Then we are going to complete pages 215 through 216, the odds, columns number 7 through 21, plus number 8 and number 22, which I actually am going to do for you right now. So let's do number 8 together. Let me pull that up. That's page 215. Okay, so number 8 says, Nick, good old Nick is famous in this one now. Nick has $7. Bagels cost 75 cents each, and a small container of cream cheese costs $1.29. Write an inequality to find the number of bagels Nick can buy. So we're going to say, we know that he has a total of $7, so that's on the right side. Put that there. And we know that he cannot spend more than $7. So that's a less than or equal to, right? His cost cannot be greater than the $7. And then that's the, I'm going to put the little line underneath it. I got to change it to black. Put the little line under there. There we go. And on the left side of the equation, we go back over here, we've got a constant rate, a one-time fee of $1.29. And then we have a 75 cents per bagel. So our case, we are going to let X, or we're going to say B equal number of bagels. So we have then, they cost 0.75 cents times the number of bagels plus his cream cheese, which is going to cost him $1.29. All should be less than or equal to, which I'm going to have to move that little line, $7. So there's our equation for number 8. And then number 22, move down a little bit. I gotta get the other page up for that. So number 22 is critical thinking. This one's a toughie, so I thought I would do this one with you. Marie scored 95, 86, and 89 on 3 science tests. She wants her average score for 6 tests to be at least 90. That at least gives you a hint that it's going to be an inequality. And we know what's going to go on the right side of that inequality, don't we? Exactly, the 90. What inequality can you write to find the average scores that she can get on her next 3 tests to meet this goal? Use S to represent the lowest average score. Well, let's put her scores here. We know how to find average, right? We average all the numbers by adding them up. Each score gets added up, and we divide by the number of numbers. However, we also need 3 more test scores, 3 more science scores. We're going to call those S. So I'm going to put that up here. Let S equal scores. So we know we have to divide to get the average. The whole thing would be divided by how many numbers do we have? How many scores do we have? Well, we can count them. We have 1, 2, 3, 4, 5, and 6. Don't let the S bother you. They're still scores, right? So we're going to have to total that up and divide by 6. That'll give us our average. And we know that the average cannot be, or can be, or needs to be. Actually, I think I could do this, couldn't I? There we go. Wish I had thought of that sooner. Can be greater than or equal to 90, right? Exactly. So that's our equation. We can actually condense that equation a little bit. We can add 95 plus 86 plus 89, and that would give us, I added that up, 270 plus. We can also combine these 3 S's here. If you combine a 1S plus a 1S plus a 1S, you end up with exactly 3S. Oops. And all of that can be divided by 6. And we're just kind of simplifying our equation. And then that has to be greater than or equal to 90. And now that I have my new little shortcut, I'm just going to put an underline there. Hey, I love that. Okay, so that's how you do number 22. So I'd like you to do the odds. I did the 2 even ones. I wanted you to do number 8 and number 22. Just go back and take a look at them. And if you have any questions in the meantime, I'm there for you. You can email me. You can check in during office hours, Mondays or Thursdays, 9 to noon. And we'll talk about that a little more in orientation this coming Monday. Actually, by the time you're watching this video, you'll probably already have had your orientation. So I hope you have a great day. I'm going to stop my share. And I'm going to say goodbye. Have a good day.